Okay, any questions? Okay. So like I said, we are going to focus today on the unit conversions themselves. And also, like I said, if you've had chemistry, this is old news. So, excuse me, when you are converting from one unit to any other unit, we have one rule, really. And that is, you will need to be multiplying by something, and that thing that you're multiplying by needs to equal 1. If I multiply by anything but 1, I change the value. Okay? Now, luckily, just multiplying by 1, that doesn't really do anything, but luckily there are literally an infinite number of ways to write the number 1. There's the boring way. But then we can get some more interesting ways as we go. Now, what's going to feel unconventional, but what works for physics, is maybe I do something like this. So in the case of, say, 2 over 2, do you agree with me that it equals 1 because the top and the bottom are equal to the same thing? Does that make sense? And when the top and the bottom equal the same thing, they cancel. Now, why is it that $1 over 4 quarters also equals 1? Bueller? Anybody? Why does $1 over 4 quarters also qualify as a way to write the number 1?
Because 4 quarters is equal to $1.
Because they're the same thing, just like 2 equals 2.
Yeah.
$1 is equal to 4 quarters. If you can write something like this, I'm not going to spell this right, equivalence. I'm going to call it a statement. It's not that that's what it's officially called, that's just what I'm going to call it. If you can show that these two things are equivalent to each other, they're the same amount of money in this case, you can make a form of the number 1 out of it. Likewise, if I say, like, let's go ahead and use this example up here. I've got meters and I've got millimeters. Can you make an equivalent statement between how many meters and how many millimeters are equal to each other? Do you remember how many millimeters in a meter? That's the easier way to go. I'll give you 2 options. First of all, I'm going to take you back to this chart. We find the prefix milli. It's right here. And where it has, let's use the numerical value instead of the scientific value. If I have a millimeter, what this is saying is 1 millimeter is the same thing as 0.001 meters. This numerical value will go with whatever unit we're using here. So I would just attach the unit to whatever number I see in the numerical value. Does that make sense? 1 millimeter is 1/1000th of a meter. Now, the one I was expecting you to say is I could go the other way and say that 1 meter is the same thing as 1,000 millimeters. And truth be told, it does not matter which of these statements you use. The math will work out either way. I'm going to go ahead and use this bottom one. But if you use a different one, the math should still work out always. So what I do is I write my special form of the number 1. I have that 1 meter, 1 meter is the same thing as 1,000 millimeters. And we have a special trick about how we put this together, because I do have 2 options for writing the number 1. I could say 1 meter over 1,000 millimeters, or I could have the upside down of that. For those of you that were in chemistry especially, which one of these is the better choice?
1,000 divided by 1.
And why do you say that?
I don't really know why I said that.
Yeah.
But, yeah, I just feel like that's the better choice.
It 100% is. And luckily, I mean, like, no disrespect at all to Miller. I think he probably did a fantastic job. But you've got a math teacher teaching you physics, math and physics right now. So we're going to talk fractions for a second. I do agree. You want meters on the bottom and millimeters on the top. And the reason for that is your fraction rules. We have a rule in math that says when you're multiplying things together, if you see something upstairs and downstairs, they can cancel. So, for example, if I had 3/5 times 2/3, mathematically, now I'm going to do this longhand first. Mathematically, that's the same thing as just top times top, bottom with bottom. This is how fractions work. And mathematically, too, I can switch the order of things I'm multiplying. And if I wanted to, I could even split them back up again. So in this case, do you see when I have the 3 on top, 3 on bottom, that's just a special form of the number 1, right? It goes away, and I'm just left with 2/5. The shortcut to that is you can just from the beginning say, I've got a 3 upstairs and a 3 downstairs. Therefore, my answer is the part that's left. It turns out with units, it's the same way. We're going to treat units as though we're multiplying them into the problem, because we really are. That's what the scale is doing for us. So notice, too, when I set this up, I did not put the numbers in yet. I need the numbers. I don't want to forget them. But I set it up first with just the units so that I can make sure I've got the right thing canceling. The easiest, and really, there are only 2 places you can make mistakes on these problems. The first one would be to pick the wrong unit. The wrong unit conversion. If I had meters on top here, but then millimeters on bottom here, they will not cancel. They won't do anything for us. They just make the problem more complicated. So at this point, I'm going to go ahead and put in my numbers. And we will do a few of these too to get you used to this. My units have canceled. I can see here that what I'm left with is 0.30. My meters have gone away. I've got 1s on the bottom, so I'm going to ignore them. And I'm multiplying it by 1,000 millimeters. And what's super convenient about the metric system, you just count how many zeros there are. And that's how many decimal places you move. I'm going to move the equal sign a little bit. That's how many decimal places you move the decimal point. I went the wrong way. Hold on. 1, 2, 3 this way. So we get 300 millimeters out of that. Okay. Give me jazz hands if you've done this sort of thing before. Okay. It's something that definitely comes up. We've done plenty of it. Okay. Can I erase more or less everything that's in red? As well as some of what's in blue. Give me jazz hands if you still need any of that. Okay. I don't want to just delete everything, so I'm going to take a moment to just erase. Just because the screen starts to feel overwhelming when I've got this much on. And I am recording this, so if you did miss something, you can go back and watch it on the recording.
Thank you.
You are welcome. Alright, so let's do this one again. We have 5 grams. We need to convert it to kilograms. We're going to need to have a special form of the number 1. What equivalence do you know between grams and kilograms? Let's start off. Let's do it this way first. Which one's bigger, a gram or a kilogram?
A gram.
A gram. No, sorry. A gram is much smaller. A gram's about the size of a paperclip. A kilogram.
Oh, yeah, my bad.
Yeah, is like, I don't know, maybe my water bottles approximately. So I'm going to give the 1 to the bigger thing, just because I think it's easier to not use decimals here. So let's say how many grams are in 1 kilogram?
Is it 1,000?
1,000. And that's where, again, we can come back here, find kilo, and find it's 1,000 grams. So, of those two, which one, and I always start in the denominator here, which one goes on bottom? Gage, you're not on mic. Okay, 3 of you are going at once now. What was that? Any of you?
Grams go on the bottom.
Grams go on bottom because I want to see these cancel. Yep, good job.
That's my little sister. Congratulating her math class.
Oh, good. All right, and then once I have the units put in the right place and I make sure things are going to cancel the way I need them to, then I put in the number. If you start with the number, what I find is your brain wants to focus on the numbers and you're more likely to make a mistake out of that and put them in the wrong order. Okay, so what this tells me is, remember with fractions, I'm going to give my 5 feet. I multiply top with top, bottom with bottom. I get 5 over 1,000. And because this time I'm dividing, it means I move my decimal point 1, 2, 3 spaces.